Okay, today we're going to talk about errors and power in hypothesis test. So when we perform a hypothesis test, we make a decision. We either reject the null or we fail to reject the null. And when you make one of these decisions, there is a possibility that you could be wrong, thus that we made an error. So there are two decisions that we make. We either reject or we fail to reject. And each could possibly be a wrong decision. Therefore, there are two types of errors. So type 1 error is when you reject the null that is really true. It is denoted by alpha. And it is the level of significance of the test. So if you're doing a 90% hypothesis test, alpha is 0.01. If you're doing a 95%, alpha is 0.05. If you're doing a 99% test, alpha is 0.01. And there is a visual of, again, the amount of error that you're measuring. So type 1, you reject the null that is true. Type 2 is when you fail to reject the null when it is false. So think FF, fail to reject a false. It's denoted by beta. So type 1 is rejecting a true null, alpha. And type 2 is failing to reject a false. Think FF, denoted by beta. Okay, so what if we suppose the null is true and we fail to reject it? So what decision have we made? Well, if it's true and we fail to reject, that means we're assuming true, and that is a correct statement. Suppose our null is false and we reject it. What decision was made? Well, if it's false and we reject it, well, that again is a correct statement. But suppose the null is true and we reject it. What decision was made? Well, if it's true and we reject it, well, we have an error. That would be a type 1, rejecting a true null. And when the null is false and we fail to reject, think FF, that is our type 2 error, beta. So how do we word statements of type 1 and type 2 errors? We decide whatever decision we decide, reject or we fail to reject, when in reality, this is true. So you replace the red underlined words with words from the actual context of the problem. So consequences, they are not the definitions of type 1 and type 2 errors. They're what happens as a result of making that incorrect decision. So consider a murder trial, and we're going to use this example a lot with hypothesis test. So what are the hypotheses? Well, our null, again, we always assume innocent, right? So we're going to assume the defendant is guilty until we have all the enough evidence to prove guilty. So what is a type 1 error? Type 1 error, again, would be deciding the defendant is guilty when really they're innocent. It would be rejecting a true null. What's a consequence if we state them as guilty when they're really innocent? A type 2 error, again, think FF, we are failing to reject a false. So we would decide the defendant is not guilty when really they are guilty. So what is the consequence of the type 1 error? Well, we got an innocent person that goes to prison. And what's the consequence of a type 2 error? If we say they're not guilty and they really are, then a guilty person goes free. So which of these errors does our society believe to be worse? Society does not want an innocent person going to prison. Okay, so therefore the defendant is always innocent until we have 100% proof that they are guilty. So type 1, that is why there must be evidence beyond a reasonable doubt. We don't want to send innocent people to jail. So every time you make a decision, you have potentially made an error. And A and B are inversely related. So as alpha increases, beta decreases. As beta increases, alpha decreases. There's a visual showing that. And the seriousness of the error types is determined by the specific situations. Depending upon the situation, type 1 or type 2 may be more serious. Again, sometimes it's whether we're talking about, is it a more serious for the company or is it more serious for the customer? Sometimes it's perspective. We often do not know if an error is actually made in real life, except for these kind of cases. And the cases would be like recalls. So Firestone tires had a huge recall. Tires started blowing up on cars, and they had to send out a recall on those, stating any tire made within the certain time frame needed to be replaced. And again, that's why most products that are made have some type of quality control number on them, so that if there's a bad batch, they know exactly what numbers were in that batch. Drugs, pharmaceuticals is often found with recalls, Vioxx. I'm sure there's tons of other ones. Again, they put out drugs, medications, over-the-counter medications, or even prescription medications, and then they don't find out till years later that they're causing more severe diseases. They don't know at the time given, so it doesn't show up till later. So someone made an error with these products. So let's look at an example. Lay's Chip Company. So Lay's Chip Company decides to accept a truckload of potatoes based upon results from a sample of potatoes from the truckload. So what are the hypotheses? Well, our null hypothesis could be that we have good potatoes, and our alternative is that we have bad potatoes. So what is a type 1 error? Type 1 error would be deciding the potatoes are bad when they are really good. Type 2 would be deciding the potatoes are good when they are really bad. So from the supplier's viewpoint, which is more serious, that would be a type 1 error. So if we're talking about who wants to buy them, okay, they don't want to buy bad potatoes. So from the chip company's viewpoint, which is more serious, a type 2. Because if Lay's company purchases the potatoes and then they're really bad, well, they have to throw out a bad batch. So a lot of times error, a more serious error, depends on whose perspective you're actually talking about. So let's look at another example. We have water samples are taken from a water used for cooling as it is being discharged from a power plant into a river. It has been determined that as long as the mean temperature of the discharged water is at most 150, there will be no negative effects of the river's ecosystem. So to investigate whether the plant is in compliance with regulations that prohibit a mean discharge of above 150 degrees, 50 water samples are taken and randomly selected times, and the temperature of each will be recorded. So in this scenario, what are the hypotheses? Our null is that our mean is 150, and our alternative is we're suspecting that it's above 150. And again, we should state that our what our mean represents. Our mean is the average temperature of the water. So what is a type 1 error? Type 1, again, would be deciding the temperature is above 150 when it is really below. Again, type 1 is rejecting a true null. Type 2, think FF. Decide the temperature isn't above 150 when it's really above. So which is more serious? Most people would agree that the type 2 would be more serious because it would endanger the river's ecosystem. Okay, so we don't want to be inserting bad chemicals into the water. That would be worse for people. So let's look at another example. A doctor is considering a new medication to help fight infections. However, the medication has the possibility of being highly toxic to patients. We will test the medication to determine toxicity. So what are the hypotheses? Well, the medicine is not toxic, and our alternative would be that it is toxic. So what are the type 1 and type 2 errors? Well, type 1 would be rejecting a true null, deciding the medicine is toxic when really it isn't. Type 2, think FF, decide the medicine isn't toxic when it really is. So which is more serious? Most would consider a type 2 error more serious since people could be harmed. Okay, so if you just don't put the medicine on the shelf, well, yeah, you're costing people money, but you're not costing lives. But if you put that medicine on the shelf and it does damage to people, that's definitely more serious. Money can be replaced, people cannot. So a government agency has received numerous complaints that a particular restaurant has been selling underweight hamburgers. The restaurant advertises that its patties are a quarter pound, 4 ounces. So again, this is the example that we did at the very beginning of this chapter to introduce this chapter. So identify the following decisions. So what if we decide the mean weight of hamburgers is less than 4 ounces when in fact they really are less? Well, if we decide they're less and they really are less, well, that's a correct decision. We made a correct statement. But what if we decide the mean weight of hamburgers is not less than 4 when in fact they really are less? That would be our think FF. Failing to reject a false would be our type 2 error. So how does one decide what alpha level to use? Well, after assessing the consequences of a type 1 and type 2 error, identify the largest alpha that is tolerable for the problem and use that alpha level for your level of significance. So moving on to power of a test. So what's the power of a test? Now that we've talked about different types of errors. The power of a test, by definition, against a specific alternative value, is the probability that the test will reject the null when the alternative is true. So again, the whole point of you performing a hypothesis test is you're thinking that maybe we suspect something else is true. In practice, we carry out the test in hope of showing that the null is true, is false. So high power is important. Again, you don't conduct a test if you're assuming they're already telling the truth. Okay, you suspect something different. So that is going to be called power. So high power is important. So again, suppose our null is true. What if we decide to fail to reject it? If it's true and we fail to reject, again, that's a correct statement. If our null is false and we decide to reject, well, if it's false and we reject the null, then again, that's a correct statement. If our null is true, what if we decide to reject it? Well, that's a type 1 denoted by alpha. And if our null is false, what if we decide to fail to reject it? That would be a type 2. So power of the test is we correctly reject a false. Again, the whole point you're conducting your hypothesis test is we assume something else is true. So we're hoping that we're going to be able to reject and make our statement claim true. So that is where we find power. Null is false and we reject. So let's look at an example. A researcher selects a random sample of size 49 from a population with standard deviation sigma equals 35 in order to test at the 1% significance level. So again, our null is that it equals 680. And our alternative is we're suspecting that mu is greater than 680. So what is the probability of committing a type 1 error? Well, type 1 error is alpha, so at the 1% significance level, alpha would be 0.01. So to give you a visual, again, right side would be rejecting the null, failing to reject HO would be the left. So alpha is rejecting HO, beta is failing to reject. And power we can write down is 1 minus beta. So what happens to alpha, beta, and power when the sample size is increased? What do we notice? As always, if our sample size increases, we're going to get more like a normal curves, tall and skinny, correct? So notice our alpha decreases here, as does beta. So facts, the researcher is free to determine the value of alpha. So again, unless stated, you can choose either 90, 95, 99 are our typical ones, but technically you could do any level. The experimenter cannot control beta since it is dependent on the alternate value. So the ideal situation is to have alpha as small as possible and power close to 1. Okay, so a good power test would be power being greater than or equal to 0.8. And again, power is 1 minus beta. And as alpha increases, power increases. But also does the chance of a type 1 error. So this is regarding certain situations, why increasing your error, yes, increases your power, but you also, again, you're increasing your error. So you need to see if increasing that chance of type 1 error is justified. So the best way to increase power without increasing alpha is to increase the sample size. So as always, if you had to guess, how do we get a more normal-like curve? How do we get it closer to approximately normal? How do we increase power? Your go-to answer is increase sample size. So a water quality control board reports that water is unsafe for drinking if the mean nitrate concentration exceeds 30, and water specimens are taken from a well. So what if we decide that the water is not safe to drink when in fact it is safe? Well, that's a type 1 error. We are rejecting a true null. You decide that the water is not safe to drink when in fact it is not safe. Well, that's a correct statement, okay? That is the pure power of the test, okay? It's not safe. When we say not safe, we've made a correct statement. And that concludes types of errors, type 1, type 2. Type 2, think FF and power of a test.